So today I want to talk about data confidentiality and peer-to-peer communication and smart contracts of blockchain in the context of Industry 4.0. I'm from the University of Furtwangen. It's in the southwest of Germany, and we are funded by the European Union. Let's talk about the agenda. I want to present a little introduction in who we are. We are an institute that focuses on IT security. Then I want to give you a little bit of an introduction into our project. It's called Blockchain in the Switch Cabinet, in which we want to integrate blockchain technology into basically the electrical box of machines, so that we can enable new and innovative production processes. Then I want to go over the motivation why we did the research. Then I want to provide you with an overview of current blockchain-based approaches and their drawbacks. Then I will present you with our proposed solution for data sharing between companies. Then I will quickly go over an evaluation that we have carried out, and then I want to draw the conclusion. So just a little bit of an sort of introduction. We are the Institute for Data Science, Cloud Computing, and IT Security. We were founded in 2009 with the focus on cloud computing and IT security, and our area of research extended now to distributed systems, cloud computing, ICT security, blockchain, industrial 4.0, and IoT in general, and also machine learning. As I mentioned before, this paper was created in the context of an currently a project that we are currently doing, and it's the BIS 4.0 project, in which we want to basically establish new ways in which we can create a continuous chain of trust for the maintenance process of machines. Our goal is to digitize service level agreements that are currently paper-based and want to transform them into a digital representation assisted by blockchain and the concept of smart contracts. And also one aspect was the control of data exchange between companies, and this will be the focus of this presentation. Our motivation was that there is an ever-increasing data exchange between companies, because there are companies that were basically for the last century kind of an information castle where no information was shared with third parties. And with the ever-increasingly utilization of technologies such as IoT, there's also an increased data exchange for the goal of, let's say, increased productivity or reduced cost. And we analyzed the process in Germany, and we have seen that there's a high risk for losing data that are serious. A recent example is that a back end of an robot automation company has leaked confidential information such as driver licenses of employees or high confidential production planning software. We furthermore analyzed blockchain because blockchain has the potential, or has shown the potential of solving so many problems in the past. The major example is Bitcoin, and we saw that the blockchain technology is ever increasingly utilized in basically every sector of industry. As always in the research, we are not the first one trying to solve the problems, so we did a literature research. Our findings was that there are 3 different categories to tackle the problem of data confidentiality. There's the concept of privacy preserving data mining, the concept of access control, and the concept of smart contract privacy. With privacy preserving data mining, everyone in the network executes computation against data to gain new information, but they don't have direct access to the data. Often the solution will also utilize off-chain databases to reduce the data volume required in a blockchain. The drawbacks that we have identified are this solution does not provide the desired peer-to-peer communication flexibility. This flexibility is needed because basically the business processes that can or could be achieved by this solution are really flexible. So let's say I'm a machine manufacturer and I don't have the capability of 3D printing something, and that I want to really quickly find someone that can print this stuff for me. So it's really hard to do that if we need to establish contracts or if we need to connect our proprietary software with each other. We also found that if the data mining platform for the privacy preserving data mining goes offline, we have data loss, so we cannot continue our operation. Also, the next problem is if the off blockchain database is unavailable, we also loses access to the data. Another approach was access control, in which blockchain is used as an access control management software. The benefits is that it enables fine-grained access control, so that we really can fine-grain define which entity is allowed to access our data. There's also often the use case of using off-chain databases to reduce the blockchain data volume, which could hinder the application of this solution. The drawbacks is also that if the data base is offline, we don't have access to the data. And here also we don't really have peer-to-peer communication flexibility. In the context of smart contract privacy, we identified a new and ever increasingly concept by many companies, especially IBM, in which the smart contract is executed in an trusted execution environment, which is basically an area of a piece of software or a hardware, such as processors, in which nobody can peek into, so that the data that is processed is really private. And here also we identified that the data exchange flexibility is not that high as we liked to have. Our solution is that we are establishing a confidentiality audit trail with blockchain, so we can later audit or analyze if the confidentiality that we want to achieve is really or has really taken place. We also defined the confidentiality smart contracts, and we established the concept of data communication modules for blockchain. With the confidentiality audit trail, we want to provide the users with a proof that their desired confidentiality was really achieved in the area of communication. We can provide companies with the evidence that some data was exchanged, but all the participants that are not allowed to peek into the data are still unable to see something was exchanged. Our solution is that, as I said, we create a transfer log. It's called an audit trail for direct data transfer. So in our solution, we don't utilize the blockchain as the vehicle for transporting the data. The blockchain is used as an untamperable log, so that we can later identify that something was transported. In addition, the data communication module is also executed in a trusted execution environment so that a malicious intruder cannot snoop on our process. The confidentiality smart contracts are used when data must be recorded into the blockchain to trigger some certain action, like the maintenance of a machine has to execute it in, let's say, 49 hours, but to protect the data against direct access, we will map the data to a quantitative description of an interval. So let's say the 49 hours are transferred to an interval of 2 days. The problem with this solution is that the possible function scope of smart contracts are somewhat hindered. So we cannot longer execute value comparisons. We just can compare intervals. And additionally, we could also include hashing of the data so that it's even harder to peek into the true information. The data communication module is the vehicle to communicate between a data sender and the receiver, and to establish somewhat of standardization so that modules from different providers are compatible with each other. We defined a process of a module certification authority. This module certification authority will check and validate the created modules to establish a somewhat level of code quality. It's also can be validated if the module acts in the way that we want. And to establish trust in these modules, or to prove that the modules are validated, we also record the certification into the blockchain so that everyone at every given time can peek at the information of the module and can say, yes, I really want to use this module because it has been verified. With this approach, the role of the blockchain shifts from being the distributed access management to being the canonical source of privacy module trust. This shift also enables us to customize the data communication module to really fit our dependencies. So let's say we could use let's say we have an IoT application in which we don't really have much storage or computation power, and we are highly constrained by energy consumption. We could then therefore modify the module to only collect data and send it further through the secure communication canal. Or let's say we have a high powerful machine, and then we could also include some validation checks. Let's say that the data type is the thing that we expected, so that let's say we expect a number and somebody want to feed through a string, so we can detect that. Or for sensor values, we could check if the data that we collected makes really sense. So let's say our expected range is between 10 and 30, and we received a value of 50. We can then could alarm the data sender that something went wrong with his sensors. We also executed an evaluation of our concept in which we defined two stakeholders: a machine owner that wants to cooperate with the machine manufacturer because he wants to switch to an on-demand maintenance plan in which the maintenance is predicted based on a number of workpieces produced. And here's the thing: the workpiece number could provide some, let's say, evil-minded information for the competitor, in which the competitor could then therefore predict the expected revenue. So we want to effectively masquerade the number of workpieces. And as a compromise, both stakeholders said, yes, we could use the mapping of the value to a value range, so the true number is not quite visible, and also we then wrap the value range to a quantitative description, so that the exact value is not known, only the value range in which the value lies. And as you can see on the right side, the machine owner collects the data. He then, in the first step, hashes the value with an salt value and records this into the blockchain as the proof that he wants to send something to the machine manufacturer. And in the next step, he maps the number, in this case 5376, to a quantitative value range which is maintenance imminent. And this value is then sent to the blockchain, and the smart contract that is in charge of the maintenance then evaluates this value. So since the message is maintenance imminent, the action notify machine manufacturer is triggered, and the machine manufacturer is therefore notified. Underneath this example, you can see a pseudo algorithm to illustrate this further. As a conclusion, it can be said that blockchain really is the next vehicle to build trust between enterprises that are working together. Audit trails can be managed by the blockchain without having to send the data through the blockchain, which would be bad, because once data is recorded into the blockchain, it's there forever. So bad for confidential data. We also defined and analyzed that private channels between enterprises can be set up dynamically. There's a wide variety of such private channels. It could be a message queue system, such as Apache Flume or something like that. We we defined that smart contracts that could be used or can be used to hash values to execute action without direct access to the original data value. We created modules that can be optimized and customized to meet the requirements of low power environments such as IoT. These modules can also be customized to meet individual privacy requirements. We designed the modules in a way that they can be certified and therefore are transparent and traceable for each participant. The outlook is that we want to implement this in our research project, which, as I said, was funded by the European Union and gained quite of interest in the last months by many little companies in our region. So thank you very much for your attention, and if you have any further question, please feel free to contact us at our email addresses, or just visit us on our website. So thank you very much, everyone. I hope it was a nice presentation for you all.